Hey there and welcome. Today we're going to dive into a really fascinating story. It's about a battle happening inside millions of homes right now, where our comfort systems are fighting a relentless, invisible enemy, the environment itself. By looking at one of the toughest places for an HVAC system to survive, we're going to uncover lessons that apply to pretty much all of us, no matter where we call home.
So let's just jump right into the big question, right? Why does a furnace or an air conditioner in a place like Centennial, Colorado, have such a harder life than one down at sea level? Well, the answer is basically a perfect storm of environmental factors that just punish these machines in ways you probably wouldn't even think of.
And this quote, man, it just perfectly captures what's at stake here. These failures, they're not a slow, gentle decline. Nope. They are sudden, catastrophic events that always seem to happen at the absolute worst moment, like the middle of a freezing night or the peak of a blistering heat wave. It's that feeling of sudden crisis we all dread.
All right, so let's formally meet the antagonist of our story, the punishing climate of Centennial, Colorado. And we're not just talking about a little snow or sun. It's a really unique combination of factors that creates a truly brutal environment for any piece of equipment to operate in.
It all starts with this one number, 5,500 feet. At this altitude, the air itself is fundamentally different. It's thinner. And that one simple fact creates this whole cascade of problems for machines that were really designed to work where the air is much denser, down at sea level.
So here's the crucial point. To move the same amount of heat through your house, a blower motor in that thin air has to spin faster and work so much harder. This constant extra strain leads to way more wear and tear, and you guessed it, premature failure.
And then you've got the temperature itself. These constant cycles of freezing nights and warmer days force the metal parts in your furnace to expand and contract over and over and over. Think of it like bending a paperclip back and forth. Eventually, that stress causes cracks. And in a furnace, a cracked heat exchanger isn't just a problem. It can be really dangerous. This chart really helps you visualize that stress. Just look at that summer swing, from a scorching 95 degrees all the way down to a cool 60. Your AC is running full blast, and then it just shuts off. That constant, rapid cycling from maximum effort to zero is just incredibly taxing on all the components, especially compressors and capacitors.
And the assault, it just doesn't stop there. The dry air means more dust is circulating, clogging up your filters. The intense high-altitude UV rays literally break down the plastics and wiring on your outdoor units. Wind is constantly blowing debris into condenser coils, basically choking them. And even in a dry climate, you can have these little microenvironments, say near a creek, that create enough humidity to cause mold in your vents. It's like a multi-front war.
Okay, so what happens when all that environmental stress finally builds up and something gives? It doesn't just cause some abstract wear and tear. No, it leads to very specific, very common, and very costly failures. Let's take a look at what actually breaks down. Now, here's a classic high-altitude problem that just seems completely backwards, right? How can your AC freeze up solid in the middle of summer? Well, when you have issues like a clogged filter that restricts airflow, the super low humidity at elevation makes it even easier for the normal condensation on the coils to flash freeze into a solid block of ice. And that can absolutely destroy your system's most expensive part, the compressor.
Another really common problem is something called short cycling. This is when your system turns on and then off, then off, every few minutes. It never gets to run for a good, long, efficient cycle. This just skyrockets your energy bills, and it's kind of like constantly starting and stopping a car engine in city traffic. It just wears everything out so much faster.
And yeah, those high-energy bills are a major pain point, and it's almost never just one single thing. All these little culprits add up. And get this, leaky ductwork alone can waste up to 30% of your heated or cooled air. That is a massive hidden cost that hits you right in the wallet every single month. The good news is, your system will often warn you before it completely dies. These are sounds and smells you absolutely cannot ignore or just hope will go away. A grinding noise? That means a motor is about to seize up. That banging sound could be a cracked heat exchanger, which is a serious carbon monoxide risk. Recognizing these signs can honestly be the difference between a simple repair and a full, incredibly expensive replacement.
Okay, so I know this all sounds pretty bleak, but it's not hopeless, not at all. The key to fighting back against this punishing environment isn't some magic new product. It's specialized technical knowledge. It's all about understanding the unique physics of how these systems work at high altitude.
This slide, right here, gets to the absolute heart of the technical solution.
You can't just take a standard furnace or AC unit out of the box and expect it to work right at 5,500 feet. The gas valves have to be adjusted for the thin air to make sure you get a safe, efficient burn. The refrigerant charge has to be totally recalibrated because pressure and temperature just behave differently up here. These aren't suggestions, they're non-negotiable adjustments.
And that technical approach also applies to how a system is even chosen for your home in the first place. You can't just guess based on square footage. A proper installation demands a detailed calculation. In the industry, they call it a manual J. It's like a blueprint for your home's unique energy needs. It looks at square footage, sure, but also your insulation, the number and type of your windows, and even the local climate data, all to make sure the equipment isn't too big or too small.
And when things do break, what does that mean for your wallet? This table kind of helps demystify the repair costs. A failed capacitor? That's a relatively simple and inexpensive fix. A blower motor is a bit more complex, a bit more money. But the compressor? Well, that's the heart of your AC system, and replacing it is a major, really expensive repair. And that's exactly why all this preventative knowledge is so important.
Okay, so let's put this all together. We've looked at the climate, the common failures, and the technical solutions. But what are the practical, actionable things you can take away from this, whether you live at high altitude or not?
This is probably the most common and, frankly, the most important question that homeowners have. In a really tough environment where your systems are constantly under stress, how often do you really need to have a pro come out and check on things?
And the answer is refreshingly clear and simple: twice a year. Think of it like you're preparing for battle. You tune up the furnace in the fall, right before the winter war begins, and you service the air conditioner in the spring, just before the summer siege. This proactive approach is the single best thing you can do to prevent those awful midnight failures.
So, if you remember anything from all this, let it be these 4 things. First, your local climate is a huge player in your system's health. Second, extreme environments like high altitude demand specialized adjustments from a knowledgeable pro. Third, that twice-a-year maintenance schedule isn't just an upsell, it's essential insurance against disaster. And finally, learning to listen to your system and knowing those warning signs empowers you to act before it's too late.
So we'll end with this thought. We've taken a really deep dive into one specific challenging place, but the core lesson here applies absolutely everywhere. Every single home has its own unique climate to deal with. The real question is your home's most important system truly prepared for the battle it has to face day in and day out?